So welcome back to all. So in this lecture I will talk about commutator. So suppose that I have a function fx, that is function of x, and there are two operators a and b. Now suppose that in this case at first b operator operating on this function fx, and it will produce some another function of x, that is gx, and after that the a operator operating on this function gx, and it will produce another function called mx. Now suppose that the ordering is now reversed. Instead of p operator operating on fx, first say that a operator is now operating on this fx, and it will produce a function cx, and after that this p operator is operating on this cx, and it will produce a function mx. So in both cases, whether b operator operating first or a operator operating first, if we obtain the same function, then we can say that these two operations are same, like p operator into a operator operating on some function fx will be equal to a operator p operator operating on some function fx. So both the ordering of the operator will give the same result. Then we can say that this a operator and b operator commute with each other. So in that case we can say that a operator p operator fx is equal to b operator a operator fx, or we can express this in shorthand. Third bracket a operator p operator will be equal to 0. So their commuter can be expressed as a operator b operator minus p operator a operator. Their commuter will be equal to 0 if a operator and p operator commute with each other. But if a operator and b operator do not commute with each other, then there can be some uncertainty relationship between them. So we will find out what is this uncertainty relationship. Now in my previous lecture I have talked about the uncertainty, which is basically standard deviation of some measurement. Now the expression of the uncertainty or the standard deviation of a can be expressed as square root of average or the expectation value of a squared minus expectation value of a squared. So this is called the uncertainty or the standard deviation of a. Similarly, the standard deviation of b will be expressed as like this. So all these things I have already discussed in my previous older lecture. So you can go through that older lecture of mine in my YouTube channel Chembiasis to understand this commutator portion better. So the uncertainty product will be equal to sigma a into sigma b. That should be always greater than or is equal to half of the magnitude of the expectation value of the commuter. So you can say, I have already talked that this is third bracket a b is called the commuter of these two operators. So their uncertainty product sigma a into sigma b will always be greater than or is equal to half of their magnitude of the expectation value of their commuter. So how this thing can be expressed, you can see that this thing can be expressed like half of magnitude some integration. To obtain the expectation value, we have to do some integration psi star, that is complex conjugate of some function psi into this commuter operator a and b operating on some function psi dx. So this is basically expression of the magnitude of the expectation value of the commuter. So now we will see that what will happen when this a operator is become a momentum operator and b operator become position operator. In that case we will see whether they will commute or not, and if they do not commute, what will be their uncertainty relationship, that you will see in the next slide. Now you can see that this is the momentum operator, expression of momentum operator px in x direction minus ih cross first derivative with respect to x, and the expression of the position operator is very simple, simply multiply with x. So all these things I have already deduced in my operator lecture, so you can go through that portion to understand this commuter portion well. So what will be the commuter of this two operator? The commuter of this two operator can be expressed as px x third bracket. So you will see that whether they will commute or not. So to see that, we have to apply this commuter to the function fx. So we apply this commuter which is another operator to the function fx. So this third bracket px x commuter can be expressed as px operator into x operator minus x operator into px operator, that is operating on some function fx. Now putting the expression of that px operator is minus I h cross first derivative of x into x, that is operating on fx, and again minus x into this p of px operator minus I h cross first derivative with respect to x into fx. Now this operator you can see that there are two functions x and fx. So at first this first derivative will operate on this function x, and then it will operate on fx. So you can see that minus I h cross the fx will be out of that differentiation fx into first derivative with respect to x, that is equal to 1. So it will produce minus I h cross fx. Now this first derivative operator will operating on this function fx. So x will be out of that differentiation, so minus I h cross x d first dfx dx. Okay, so this is the first part. Now in this case x is out of that differentiation, and there are two minus, so it will produce plus x I h cross dfx dx. So you can see that these two will cancel out, so the final thing we will obtain that minus I h cross fx. So if this commuter is operating on some function fx, it will produce minus I h cross fx. So the expression of their commuter is px x third bracket is equal to minus I h cross. So this is not equal to 0. So we can say that the position operator and momentum operator do not commute with each other. Now again I have to talk that about the uncertainty product. The uncertainty of product of sigma x and sigma px can be expressed as they will be always greater than or is equal to half of the magnitude of their expectation value of their commuter. So how we can determine this thing? So it will be equal greater than or equal to half. We have to do the integration. This is the magnitude of the integration. Psi star is any function, that is a function of x, and this is the commuter operator pxx, that is operating on some function psi x dx. So we know that we have derived that this commuter, the expression of this operator will be equal to simply minus I h cross. So we will put simply minus I h cross instead of this commuting operator commutator minus I h cross. Now this minus I h cross, as it is not a function of x, so it will be out of that integral. So we will get integration psi star x psi x dx. Now as it is a normalized wave function, so the value of this one will be equal to 1, because there is a 100% probability of finding that particle in between minus infinite to plus infinite. So as it is a normalized wave function, this integral will be equal to 1. So you can see that the uncertainty product of sigma x sigma px will always be greater than or is equal to half magnitude of minus I h cross. So if you do the mathematics in complex number, the magnitude of minus I h cross is equal to h cross. So you can see that sigma x into sigma px will always be greater than or is equal to h cross by 2. So this thing I have already derived in my previous lecture, and also from this commutator portion also we can see that the uncertainty product between the position and momentum of a particle will always be greater than or is equal to h cross by 2. So this is basically nothing but the mathematical expression of Heisenberg's uncertainty principle. which shows that we cannot determine simultaneously the exact position and exact momentum of a particle. So there can be always a uncertainty relationship between them, and this is the mathematical expression of that uncertainty product of that momentum and their position, which is expressed as greater than or is equal to h cross by 2, and which can be deduced from the simple commutator operator. So that's all from this commutator portion. So if you do have any questions regarding this lecture, you can ask me through the comment section, and take care of yourself. Bye.